So, welcome to today's course. So there's going to be a little bit of a shuffling around of material because you guys are going to have an assignment to do during the lecture break, which is in a couple of weeks. And Mark, I think, was planning on coming in later today to talk about it, to give you guys a sort of heads up so you can start thinking about it now. But yeah, he wants to do some hardware prototyping, which I wasn't actually going to approach until afterwards, but now we're going to have to do it before the course. So things will be a little bit out of order. We'll still cover everything. It might just be not in the order that you would expect, but that's okay. So what we'll do is we will just finish off with the C stuff we're looking at, and maybe look at a little bit of open frameworks, but then we'll start looking at hardware prototyping just so we can cover enough of it to give you guys enough knowledge to do this assignment. So if you remember where we left off yesterday, we were looking at C programming, and we looked at various data structures, so structs, classes, namespaces, so on and so forth. And then we got to pointers, and I decided that was as good a place as any to stop. So unfortunately, we're going to have to cover them eventually. So why not now? And we'll look at a bit of memory management as well. So a pointer points to an address in memory. When you put it like that, it sounds quite simple. In practicality, it's actually kind of difficult. So get your head around. So let's say, we've all seen this before, int x equals 6. So basically, we have a piece of memory somewhere. So over here, we have this piece of memory, and inside it, we put the number 6. So when we say what's in x, like if you think of these as like boxes or, I don't know, pigeonholes in you know how you have pigeonholes when you're at school and each one's got someone's name on it and you can put stuff in there. Yeah, so in the pigeonhole for x, we put in the value 6, and that way if we ever ask what is in x, we say 6. So a pointer, we can create a pointer by basically, in C, by putting the star in front of that, and that basically says it points to the value of an int. So essentially what's happening is we have this pigeonhole y now, and we're saying, okay, and if we can get a pointer to a variable by using the ampersand. So basically what we're saying here is we're saying, well, y isn't actually going to hold a value itself. So y isn't going to hold the number 1 or whatever. It's actually going to point to another piece of memory. So we say, okay, well, let's create our pointer y, and we're going to point that to the address of x. So we're basically saying that y now points to x. So if we said, okay, what's inside y, we'd actually get the address in memory where x is. So this is just one. This is sort of typically what you'd look at. So if you tried to print out y, you'd get something which kind of looks like this: 0 times 00C30061, which basically says where in the address space x is. And then we can dereference that to find what's actually in x. We can also do what's known as dereferencing. So when we see we have this int z equals y now, so this is just an int z, so we know it's actually going to store a value. It's not going to store an address to a value. And what we do is when we have the star here, it's what's known as dereferencing. So basically this is like saying, okay, we're not actually interested in what is in y, we're interested in what y points to. So when we say this, we say, okay, z, we want that to set to whatever y points to. So we say, okay, we'll create this new pigeonhole z. We'll come over here and we'll say, okay, y points to 0x00C3, which is this part of memory. And we'll look in here, and this is 6. So we'll go, okay, we'll store in there what 6 is. So y is implicitly linked to x in this case. If we change the value of x here to 7, this value will stay the same. But if we did this call here, this would be 7 now. So let's see a little example, because it's typically easier to sort of see these things in action. So
you don't have to explain this. How do you get a memory address like that?
In what respect? Like how is it 0 times?
You don't have to explain it.
Yeah, it's. I mean, I'm sort of. I have a vague understanding of how it works, but that's like it's just all allocated in groups of memory, and then your program when it runs, it's even before registers. So registers usually get registers are typically run on the places that you put data into, and then you call an action, and then it affects what's in the registers. So registers are sort of like operational memory, whereas this is more like, more long-term memory. Well, I guess for long-term memory is the hard drive. Short-term memory is what we're talking about here, and then you have operational memory, which is the registers that you put stuff into, and it operates on that. Basically, you get what's known as your stack, which is memory which is allocated to the program, and then as it goes, it starts at the top of the stack and gradually starts allocating memory as it goes down. So when we create the value of x, it looks for the next available address, and the next available address in this case was 00C30061 or whatever. And then when we create our values y, it will actually be stored at like the next available address after that, and z will be the next one after that. So you can actually, if you look at these values, often you'll see that their addresses are consecutive because the memory gets allocated consecutively. But yeah, it's quite a sort of in-depth process at how it works. But let's have a look at some examples of this stuff working. Right, so void main. And let's run the example that we have now. So int x, int y equals the address of x. So this is essentially the address of, and then we can say int z equals the value of in y. And now we go print percentage sign d, percentage sign d. To include. Right, so so the good thing again with Visual Studio is we can do lots of nice debugging stuff, so we can put a breakpoint in there and actually see what's happening. There it goes. So pull this one over. So you see here, basically, it's created this value x. Currently, we haven't actually set anything to it, so it's just got whatever was sitting in that piece of memory at the time, which was some rubbish number. But after we set that, x is now set to 6, and now I've created y. Y is a pointer, so y is pointing to some garbage thing. And you can see here, this is our address of x in our memory, so 0x00. 3BFC5C. So when we step over that, we'll see that y is now pointing to x, and now we have z, and we're going to say, okay, z gets what's dereferenced in y. So essentially what it's doing is it's going to open this up, and it's going to say, okay, what piece of memory does this point to? Well, it points to this piece of memory, and inside this piece of memory is the value 6. And so it's going to copy that value into z. And there we go. So now x is pointing to 6. Let me open up this one. X is 6, z is 6, and y points to this piece of memory, which happens to be the address where x is. So if I was to break this now, and let's say x equals 7 down here, and let's run that again. So you see x is 6, y is pointing to, so x now has this address in memory, so it changes when we run the program because we just get allocated a chunk of memory and told that that's what we have to work within. So x is 6, and then y points to x, and z gets the value of what y points to. Now if we jump down here, you'll notice when we set x to 7, that value changes to 7, and the value that y is pointing to also changes to 7. So y is essentially just literally pointing to a piece of data and saying, I am pointing to whatever is stored in this value. So you might be asking, why would you do that? Well, in some cases in C, you have to, and that's the main reason I'm covering it. Pointers can be quite powerful if you know what you're doing. And there's lots of clever little tricks you can do with like iterating over an array, using a pointer into the array, and then just adding across every piece of memory. But we're not going to go into that because while it's quite tricky, it's a really good way to screw up your program and crash it. Yeah, and there's an old saying which I think is quite true, like C is really powerful, but it also makes it incredibly easy to shoot yourself in the foot. And it's that sort of case that the more you play with these powerful features, the more likely you are to screw something up. So, but we're just going to look at it because oftentimes, if you're calling other libraries, you'll need to know how to create a pointer and pass it into it. So yeah, we define a pointer using the star symbol. So int star y means that this is going to be, y is going to be a pointer to an int. And we get a pointer by referencing using the ampersand operator. So any other variable with an ampersand will return a pointer to where that variable resides in memory. And we can find out what a pointer is pointing at by dereferencing using the star operator. So y points to some memory address, star y points to whatever that is inside what that memory address points to. Yep, so when we have a pointer to non-primitive data types, so primitive data types are things like integers, floats, booleans, stuff like that. Non-primitives are pretty much anything which doesn't fall in that group, so classes, structs, etc., etc. Instead of using the dot member accessor, so you should remember this example from yesterday. Struct person, they have a first name, a last name, which is strings, and an age, which is an integer. We create a person P1, just ignore this line for the moment, and if we want to access the person's first name, we go P1 dot first name equals whatever. If we're doing a pointer, so now we have person star P2, so this is a pointer to a person. If we want to access its members, we use this accessor here, which is a line and a pointing, greater than arrow. So let's just see an example of that now. Where's my mouse pointer? So let's do our struct person. I need to include string. I'm just going to make it a little bit simpler. String name, age, person 1, 2. So we go p1.name equals Jim. P2 name. So you'll see again, if I try and do dot there, it's just going to say down here, IntelliSense no members available, because where it's a pointer to a memory address, it doesn't have any members. There's like a memory address, if we look at P2, would just be something like that. You can't get a name out of that, so we need to say, okay, let's grab what's in P2 and then do the name like that. Alternately, if you want to get really tricky, you could do star P2, which, as we remember, dereferences it, finds out what's in it, and then do dot name. But that's all. These two things are essentially the same thing. This one's just looking. This one's sort of a bit confusing. However, if we run this now, it's going to complain because I didn't put some colon there. So we have P1 and P2. Now again, if we look at this, P1 has a name and an age. They don't actually have anything stored in them at the moment, so it's just garbage values. And P2, we can see up here, actually points to a memory address, 0 times CCCCCC. And Visual Studio is smart enough to know that if I open that up, that it should actually be a person, so it tries to resolve that. But anyway, so if I execute this first line of code, we set P1's name to Jim, so the name is Jim. However, when we try and dereference P2, P2 is pointing to this garbage piece of memory out here, 0 times CCCC, and it will tell us that variable P2 is being used without being initialized, because it's pointing to a garbage piece of memory, and we're saying, okay, that garbage piece of memory is a person, tries to access it, and it says, well, it's not, because there's no person data in here, and so it craps out. Which brings me to my next point. Doesn't. Brings me to 2 points later. We'll come back to that one. That when we try and run this, here we go. So runtime check failure 3, variable P2 has been used without being initialized. So this was using an older version of Visual Studio, which is why it looks a little bit different. So when we create a pointer by default, it points to nothing. It will give errors if we try to use it. So we try and use this p2.firstname before we've actually said p2 is anything, and I'll say, well, you haven't actually initialized that piece of memory yet, so I can't use it. So what we need to do is allocate some memory. So we can create a pointer using person p2, and we could either set that to point to the address of person p1, but if we want to create a new one, we use the new keyword. So person p2 equals new person, and then let's go back to, whoops, where are we? Go back to this. So person p2 equals new person. And let's try running this again. So now we'll see P2 is 0 times CCCCC, so it's pointing to a garbage piece of memory. But once it runs this new person part, you'll see now it points at a different part of memory. So it's basically allocated some space, so this space should hold a person, and point P2 at it. So P2 now points at 0 times blah, 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 and we can see when we look into that, we've got a valid person now, and we can set that person's name to Bob. However, C, when we're dealing with this sort of stuff, is not smart enough to know that at the end of it, it has to free up this memory. So we need to tell it to delete P2 at the end, otherwise that memory will stay allocated in our program, and that's where you get memory leaks from. In this case, P2 isn't going to be particularly huge, so it's probably not a big problem. But when you're working with things like computer vision, where you deal with images, which might often be a portion of a meg, and you get 30 frames a second, that's 30 megs a second, you can see very quickly that you're going to run out of memory. Even if you've got 8 gigs of memory, you might get a minute or two before you've run out of memory, and then your computer grinds to a complete halt. And if you're lucky, you can exit out of the program and Windows will recover some of the memory. If not, you will have to do a hard reset, which I've had to do numerous times in my life because I've done something where I've allocated a bit of memory and forgotten to get rid of it afterwards. But as a little example, let's do this. So we can go into processes, and when we run our program, this is just the Control-Alt-Delete window, or Control-Alt-Escape if we do it that way. And somewhere in here we will have test. So this is the program that we're running now. This is the amount of memory that it's got allocated. So when I hit, so this is currently what's in its working set. The peak working set is the most amount of memory which has been allocated so far. So this, peak working set will fluctuate up and down, and working set will fluctuate up and down, and peak will always tell us the highest value, so we can find out what the most amount of memory has been running. So at the moment it's sitting at 2 megs in the memory. When I run this, it hasn't made a difference because obviously we still haven't exceeded our stack space. We haven't exceeded our stack space, so we got given a chunk of memory. We said, okay, you can work within the confines of that memory. We've allocated some space saying new person, and it said, okay, well, you still haven't exceeded your memory, so we're not going to increase it. But let's change this now so that we're going to do a loop. Hopefully that won't be enough to crash our computer. Right.
That's point is greater than
yeah. So what
was changing at this point?
No. So every time we call new, it's going to allocate a new piece of memory.
But your point is just moving along to the next piece of memory.
Yep. So every time, and in fact we can show that. So in here, P2 is 0 times 0.5 blah blah blah, and now it's 0.5448. Now it's 4FO. Now it's 598, and so this is what I was talking about. It's gradually, you'll notice these numbers are gradually increasing. They are in hexadecimal. Memory addresses are always displayed in hexadecimal, but basically it keeps going, okay, this part of memory has been used, let's grab the next part, allocate that, and then set P to it. So, we start with our first chunk of memory, we say P2 points to that, and then we loop around, we go create a new part, set P2 to that, new part, set P2 to that. And so gradually we're filling up our stack. And what we'll notice, hopefully, is over time, so if we watch this memory working set for our test method here, eventually it will exceed that down. There we go. So it's just jumped up. It's now 3,500. So not a huge amount of extra memory has been allocated, but
What's the
3,500. This one here. Got a private working set. I'm not sure what that refers to, but I mean these are the two that we're looking at here. So you can see these numbers are slowly going up. If I just run that again. It's just scanf allows us to wait for something to come into the input so we can stop it. Yeah. So let's say at the start we have 2,444 kilobytes, and at the end we have 2,608. So not a huge change, but I mean all these people store is a string with a name and an age in there, so it's not a huge amount of data if we made this bigger. But you can see even doing 1,000 things, 1,000 strings and 1,000 ages, it's already allocated another 200 kilobytes. And that's 200 kilobytes, which is never going to be freed until we delete it. So yeah, just something to keep in mind.
So normally, how do you keep the reference so that whenever you want to delete them?
well, normally, yeah, you need the
Pointer.
pointer what you use.
Immediately.
Yeah, the way Adrian said it now, there's 999 that it calculates.
Yeah.
It lost the reference to them.
Well, actually, none of them I can delete because the scope of this only lasts this long.
When you create the persons.
Yeah, so the scope of the person P2 will only exist within this for loop.
And then it will die afterwards.
Well, the P2 variable will, but the memory is still allocated.
Yeah, that's what I mean.
Yeah.
You can never find the memory again.
Yeah, but that's for all 1,000 of them.
Really?
Yeah. So if I wanted to be able to delete them afterwards, I'd have to actually declare
Because you
person
can't do
P2 there, and then say P2 equals that. And then I could delete that one, and that would delete our last person, but the rest of them would be lost. And that's kind of that's where playing with pointers can be kind of dangerous, because if you allocate some memory and then you do something with the pointer, change the pointer, you can't find that memory again. And to delete it, you need to tell it where the memory is. So in this case, we allocate 1,000 pieces of memory, but we only ever store the location of the last one. So we can only ever delete the last one. We can't delete any of the earlier ones.
And that is memory.
That is a memory leak, yep. Yeah, remember to free or delete memory, or you have a memory leak. So what was this post reference?
They're actually hard to debug.
They are. There are actually tools which can do it, which can help out, and there are actually some which are built into Visual Studio as well, which can be quite useful, but I'm not going to go into that because that's outside the scope. But if you're interested, come and talk to me and I can show you someone. Right, so this is actually sort of why we want to cover pointers. So
Doesn't Java free up memory yet? Doesn't have any Java stuff?
that's correct, Java does, but C doesn't. So this is why we didn't cover any of the stuff when we're looking at processing, because you don't have to worry about it. Yeah. And then let's do the same. So I'm just going to copy this piece of code to show you the sort of stuff you might encounter in C programming, which is why we need to use
Let's see in Java.
That's because you work with it for 7 years.
Up on us, suppose.
It's like asking what's better, apples or oranges.
Yes, exactly.
Oranges don't even factor into the equation. Right. So, okay, so we've got this chunk of code here. And basically what this chunk of code does is we have two variables. We have x and we have y. And we print the value of x, we call modify x, and then we print the value of x again. So before and after we call modify x. We do the same thing for y, print y before, print y after. The difference is modify x takes an integer, increments it, and then is done. Modify y takes a pointer to an integer, modifies it, and then returns. So does anyone have any idea of what we're likely to see? So what's going to happen when we print x before and after? Yep. So what's going to happen is we run this code, we set x to 0. So let's set x to 0, and then we print x before is 0. Now we call modify x, and this isn't actually passing in the x value, it's pointing in what, or the x memory address, it's just pointing in what's inside x. So it passes in the value of 0, we add 1 to 0, becomes 1, we return, but this x is still 0. So when we print that, it's still 0. With y, before is 0, but here we're actually passing in a pointer to the memory address. So we're passing in 0, this one we passed in the value 0, here we pass in 0 times 002 AF86C. So we're actually passing in this pointer. Now when we increment it, so if you remember, the star y basically gets the value, so we're accessing into that memory, adding 1 to it. So you see at the moment that memory address has a 0 inside it. Now it's got 1 in it. And this y is now holds the value of 1 because we've actually given it the memory address, we've modified what's in that memory address, and so now when we're pointing back at it, whoop, I've just pushed the wrong button. There we go, so y is 1. So this is quite a common sort of thing to see in C. You see some methods which take just a value, you pass in a value, and it's happy with that. Other methods will want you to pass in a pointer to that value, and that often means that it might actually manipulate the data in there. So, you know, yeah, two things you have to consider is 1, what am I passing in, and 2, what is happening to my data when I pass it in. So, you know, here we know because we're only passing in an integer that our copy of x is going to remain untouched. And this one we're passing a pointer, so we have to think, okay, we don't know that y is going to be the same before and after this call. Something in this method might have messed with it. So, yeah.
What happens if you pass in x as a reference, or at the very top have it as a reference, not a point? Isn't that modified?
How do you mean?
See the way you go modify x and in brackets.
Into x.
If that was set as a reference and not a pointer, wouldn't that?
So like that?
No, the other one. The squiggly weird line.
That one?
Yeah.
Yeah, so that's a different method again.
That would change the value of x, right?
Yeah, I think so. But we're not going to go into that because that one's actually less common. Well, in my experience anyway, it's less common. And yeah.
Or would you do the same thing down at the bottom though? If that was accepting an int, could you pass in the reference x and modify x? Like you did for y and what that keep?
So like that.
Yeah.
If that one was like this.
Yep.
Yep. So basically what's happening now is we're passing in we're trying to pass in a memory address, but it's only accepting an integer, so it's giving us an error argument of type int pointer is incompatible. So we're basically, it's expecting a number, you know, from 1 to a large number, and we're saying, here's a memory address, and it says, well, I don't know how to work with this.
But then if you had that as a reference in the method, it would work.
Yeah, so this is actually doing this, is actually passing it by reference, which is something which you see less commonly in C. And I mean, on the main reason I'm sort of touching on this is less about teaching you guys how to do this and more that if you're calling a method which requires a pointer, how you can use it rather than how you can write these things yourself. Mainly because if you're using OpenCV, you'll see everywhere in OpenCV, void CV, let's say filter, you're going to see that sort of function everywhere in OpenCV. So everything in OpenCV takes a pointer to something. There's very few functions in OpenCV which don't actually use pointers. Oh yeah, sorry, OpenCV is computer vision, so we will look at that after the midterm break.
Yeah.
Right, so that sort of covers. Does anyone have any questions? I know it's kind of complicated. No, everyone's kind of happy. All right.
I was told if you don't know how to use pointers, don't use them.
Yeah, and that would generally be my advice as well, except if you are using other libraries, you might not have the choice, which is why I felt it was important to cover them, especially when you look at things like OpenCV, where you don't have a choice. There is no way around there's no way around using them. Right, so with that, let's go to Open Frameworks. So we're going to have a really quick blast through introduction to Open Frameworks today, and then we're going to revisit after the break because I want to save next week for looking at hardware prototyping. So, Open Frameworks, .cc. I'm not sure what the CC stands for, but we already looked at the website yesterday anyway, so it's basically the same sort of thing for processing, as processing, but it runs in C rather than Java. So we have our downloads, documentations, tutorials, galleries, blah, blah, blah. We already looked at the download page yesterday and sort of talked about how the latest version only runs on Visual Studio 2012 and the older ones run on 2010. Spoke with Lee about this. He recommends you guys just use DreamSpark to download Visual Studio 2012, and we just do everything in 2012, simply because chances are uni is eventually going to adopt 2012 anyway, and then it won't matter. In fact, I think he's already put a request through to get a license for the lab. And worst case scenario, you can use the Visual Studio Express edition, which is free. It's just missing some of the features which you're probably not likely to be using anyway. Certainly, I don't know what features it's missing because I've never come across them. So yeah, open source toolkit designed for creative coding. And essentially it's a framework. So it's a collection of libraries. So we've seen this in processing as well. You have these libraries that other people write which add functionality. So we had the GUI library, Control P5, and a bunch of other ones that we looked at. This is exactly the same thing in C++. So people write a library like OpenCV, which does computer vision processing, and they just compile it up into a library that you can just put into your code, and then you can use all the stuff they've written without having to write it yourself. So they're providing functionality to you in the form of libraries. What the problem is that often getting these libraries working is a huge amount of work. So let's see if I've actually got what's going on here. That's packed as sad. Let me just see if I've got OpenCV. I do have OpenCV installed on here. All right. So I'm going to show you how we create an OpenCV project, which does almost nothing. New project. My OpenCV project. No, I do not want to save that. Right. Oh, I don't want to push that. Add new item. Main.cv. All right. So we now have something we can write code in. Let's include OpenCV. Oh, OpenCV is not there, so we need to tell it where it needs to look for it. So let's go over here, and we need to go here and tell it what additional include directories we're looking for. And say, okay, OpenCV is in C drive. Program files, OpenCV, we'll do that one. And here, there we go. Not that directory there. That one. Okay. Include OpenCV, or we'll do C. Oh, there we went. Grab the wrong folder. Sorry. So this is the sort of stuff you're dealing with when you're trying to include other libraries. Why does this keep going? So let's actually build include. That's the correct include directory this time. Hopefully, 2.4.4.http include cd2 ID. Oh, so now I've got those included. Let's write some code, void main, IPL image, my image, create image. So I do this all the time. That's why I know how to write all this code pretty implicitly. You won't have to be doing this stuff you guys are doing, and it's just hopefully by the end of it you'll be able to at least understand what I'm writing. CV show image, my image. Right. So I've written my code here. Basically, this code creates an image of size 640 by 480, 8-bit depth, and 3 color channels. We're going to set everything to 0, which will effectively set it to black. Then we're going to create a new window called My Image and display my image in it. And then we're going to wait an infinitely long amount of time for the person to press a key, and then the program's going to exit. And so I go, yay, I'm finished, and I build it. And it goes, oh no, sorry, we're not finished, because you've told me where the include files are, but you haven't actually told me where the library files are. So an include file essentially is just these .h files that we looked at the other day, which tell us what these functions look like, but it doesn't actually tell us how these functions work. So we need to then go, okay, well, let's look, see where these link file is. Now I have to go into here, go into this one, and here. This is going to be program files, OpenCV, that one, that one, that one, that one, that one. Yep. So now we've specified where it is, and now we need to tell it which libraries we need. Oh, that's on this screen again. OpenCV core 2.5. Okay. Now if we build, I can. And there we go. It only took me that long to draw a black box in a window. So you can see why this is not ideal, particularly for people who are starting new projects. So the whole idea behind open frameworks is it provides all these libraries which have already been built for you, because the other thing is I actually had to build OpenCV before I used it, which took me pretty close to an hour. And that was using CMake, which if you don't know how to use CMake, you're screwed. So, I mean, it's just this huge, huge learning curve to use some of these libraries. So the whole idea behind open frameworks is they provide the libraries have been compiled for you. They provide what's known as the project generator, which you just click a couple of buttons and it does everything that I just did in less than a second. So that's what it's there for. They also provide a common interface. So if you use the OpenCV library and then you use the OpenAL, which is the audio language, the two of them look completely different. You're going to have to learn how to write a program in one of them, learn how to write a program in two of them, just so you can use the two of them together. And it just becomes this huge big thing. Everyone does things in their own style, and for somebody to come along and use them it's too much to ask, really. It's way too much work. So, what's that? Yeah. Well, the idea behind open frameworks is it's sort of trying to bring the simplicity of processing to C. So they provide all the libraries for you. So there'll be ones for OpenCV, there'll be ones for OpenAL, all that sort of stuff. And they've written a common interface for them. So all the commands look kind of the same. They all take all the ways you call the methods are the same. All the variables and data types they take are the same. So it sort of provides this unified thing.
Is that the difference between a binary and a build when you're trying to download it from a website?
Yes, typically. So a build you have to compile yourself. A binary is typically compiled for you. So, whoops. If we look at this is my OpenCV directory. Let's actually have a look. Well, that one has nothing. That's hopeless. So this is a binary build. So it includes has our include files, and it also has all our libs, our library files in here. I do actually have OpenCV 2.4.5. So this is actually the full one, the latest, 2.4.8, sorry. This is the latest build of OpenCV. And it's going to ask to extract it from the desktop, and I'll start extracting it. And at the moment, we're looking at it's going to be about 10 minutes just to extract it. That's not counting the time it's going to take to build it on top of that. So there is an absolute ton of files. Oh, no, it's up to 12 minutes. Still going. There's a ton of files in there. There's a lot of work to get started. So let's have a look at Open Frameworks instead. Wait, did I just say I didn't want to cancel and I cancelled? Okay, never mind. Right, so, oh, why is that not dragging? So here is Open Frameworks. If we look in here, we have libs, and these are all the libraries that they provide by default. So there's things in here for image types. FreeType is a graphics. They contain a lot of OpenGL stuff. OpenSSL, so that's the secure sockets layer if you want to do like encryption, that sort of stuff. QuickTime for videos, video input for capturing from cameras, and so on and so forth. And this is the project generator. So remember before I went through and I set up all my include paths in my library directories. So let's say we want to do the same thing with Open Frameworks. I double click on this, and this window pops up, and it says, what do I want to call it? Well, they call it sketches, just like in processing. Where do I want to save it, and what libraries do I want to use? So let's go in here, say I want to use OpenCV, back, generate. And now when I go into the path I just put it into, so apps, my sketch, I open this one, 12, and let's just use it.
Is this an example? Is it?
Yep. Well, so this is essentially I've just done in processing, in Open Frameworks, the same thing that I did in Visual Studio before. And now I am ready to go. So I just have to type in here, include, what is it, OFX.
Once you set it up the first time with Visual Studio, you don't have to do the whole setup.
No. So once per project. But in this, that thing I did with Project Generator has just done all that work for me. So everything's ready to go. It all works, and all the functionality is there for us, and then we're ready to start writing code. And as similar to processing, I go on here and go into add-ons. So I showed you all those add-ons that it already provides. But if we go into add-ons, which apparently is its own site now, they've got stuff in there for using the Connect, face tracking, OFX UI, user interface thing, OpenNI, which is a Connect-based thing, OpenCV, a physics engine, all sorts of stuff, Leap Motion, and all of these are built for you. You just download them.
Oh, Leap.
Yep. So let's say we want to use the Leap Motion. Yep. Leap Motion. So grab this. It's no fun, unfortunately. So grab from there, but almost done. And now, if we want to be able to use the Leap Motion plugin, we just go to here, into add-ons, and then we just drag that into there. And then say we want to start a new project using the Leap. Fire up the project generator. Let's call it my sketch. And add-ons, OFX, Leap Motion, that. Generate. And now when we open that project, it's got all the stuff in there we need to use the Leap Motion. So it's nice and quick to get things up and running.
May I ask what Leap Motion is?
Oh, so Leap Motion, we have them in the lab. They're a little little device about yay big, which generate 3D point clouds of whatever's above them, so your hands, stuff like that.
Kind of like a mini
Yeah, a Kinect, but it's about that big, and it does a volume of sort of maybe 30 centimeters squared, but it's highly accurate. It's down to like sub-millimeter, I think they claim. So it's quite cool. Yeah, but that's sort of, you know, what you're sort of looking at for open frameworks. It basically provides all these libraries, just like processing does. Runs on Mac, Windows, and Linux, and iOS and Android with a little bit of work. However, unlike processing, it doesn't provide its own IDE, so we have to use Visual Studio, or if we're on Mac, we can use Xcode, or if we're on any platform, we can use CodeBlocks, which is a free one. So, you know, you can sort of see how it's quite similar to processing in a lot of ways. It provides the libraries we want to use. It makes setup and running a lot easier, and yeah, just makes life a lot easier. So the whole idea behind open frameworks is it's supposed to tie media stuff in there. So you see by default it comes. Actually, let's open up the project generator one more time. So by default, it comes with add-ons for loading 3D models, obviously another model loader. It has a GUI-based stuff built into it. It's got stuff for the Kinect, OpenCV, scalable vector graphics, a threaded image loader, vector graphics, all that stuff by default. These are the ones that I've added. It can interface with hardware quite nicely, which if we were doing these lectures in the right order, we'd segment nicely into, but we're going to sort of skip that and come back to it. And communications, you can see by default in here we have some network control and stuff like that, so we can network our programs quite easily. So why would we use it instead of processing? Well, at speed, C is faster than Java. That's just the facts. Java's certainly caught up a lot in recent days, and there are various other things you can do. You can compile it to almost machine code, but C still has the advantage that it is faster than Java. Java has other advantages because it's an interpreted language. It's a write once, run anywhere, so you write it and it'll run on Mac, Linux, blah, 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 whereas C, you have to recompile it, so on and so forth. But if you need the raw speed, if you're doing a lot of computer vision processing, a lot of high def, high quality graphics, you know, you're going to eventually hit a roadblock in processing, and then it's time to move to open frameworks. You can do accessibility of low-level information. So pointers are a real pain to work with, but they actually allow us to do some really clever stuff interacting with hardware and stuff like that, because we can just basically write straight into the hardware, right into the memory of the hardware and do stuff like that, which we could not otherwise do. There's also a lot of really cool and clever stuff we can do with like memory injection, so we can actually hijack another program and start modifying that other program. So that's why it's like things like C and even lower level languages are the languages of hackers, because you can do it exposes you to a lot of stuff which Java tries to sort of hide from you, because if you play with that stuff, you are fairly likely to break something, but sometimes you have to play with that stuff. The processing IDE does not include a debugger or autocomplete, which is my biggest gripe about it. You can use Eclipse, but then you have to set it up yourself, which is kind of a pain. Visual Studio has a great debugger. It's got great autocomplete in there. As you just saw, I start typing and it tells me these are all the methods that this thing provides. These are all the include files you can include, blah, blah, blah. If you're like me and are more familiar with C and C++ than you are with Java, well, and version control. So you can do version control in processing as well, but again, you have to set it up. Visual Studio has lots of plugins which do version control for you. So if you want to back up your stuff on the internet, if you want to share it with other people, you can do that stuff in Visual Studio, but in processing, you'd have to, again, jump into Eclipse to do it. So put it in a nice, simple layout. Open Frameworks makes C anyway easy to use. It's all open source, so you can write your own plugins. If something doesn't work, you can fix it. And it has a heavy focus on interactivity. So a lot of the libraries come by default provided that sort of interactivity, and the underlying code as well has all that sort of interactivity stuff. The cons is it's still experimental, and as part of that, we see this thing where older versions don't run on newer 0.8.1 requires Visual Studio 2012, won't run in 2010 unless you recompile it yourself, and back and forward. And some of the libraries, you'll see they don't only work on the older version, not the newer version, or they only work on the newer version, not the older version. So there's all this sort of, it's still in a constant state of flux. Processing is a bit more mature, a bit more stable, although I know at least Murray ran into one internal library bug when trying to do his project for Christoph. So, processing's not perfect either, but it's probably a bit further along than Open Frameworks, and it's not complete either, so there's still missing bits and pieces here and there, which we'd really like. Let's see. Yeah, so we'll do a couple more of these slides, and then we'll have a bit of a break, and then we'll move on. So this is how Open Frameworks works. I closed it. Oh no, there it is. So, no, that's not it. Hold on, I'll open up my Open Frameworks sketch that I just created. So this is the one. This is the one I just created, which uses the Leap Motion. And you see essentially in our solution we have my sketch, which is all my stuff in the Open Frameworks lib, which you should not worry about. So if we go in here and we go into the source folder, you see we've got 3 files, main.cpp, testapp.cpp, and testapp.h. So main.cpp is created for us and filled out by Open Frameworks, and we shouldn't really need to worry about it because it basically sets up OpenGL and starts our app running. What we're really concerned with is testapp.h and testapp.c. Now, when we look at this, you might notice this looks a wee bit familiar. So we have a setup function, we have an update function, and we have a draw function. In processing, we have a setup function, we have a draw function, and is it called update? What's it called? Is it? There's the other. No, there's another function which runs when draw doesn't run. I can't remember what the name of it is, which is quite bad. So we just covered this not that long ago. But yeah, these are the same 3 functions which we have in processing, and believe it or not, they work in the same way. So setup gets called when our program first runs, update gets called as fast as it can, draw gets called every time the window's ready to draw, and then we have some other functions as well. So when a key's pressed, when a key's released, when the mouse is moved, when the mouse is dragged, when the mouse is pressed, mouse released, blah, 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 blah. So yeah, it's written in a way that it's actually, all the code is set out quite similar to how processing sets stuff out. So yeah, we have our main.cpp, which calls our app. So this is where we write our code in these 2 functions. And then we can build on all these Open Frameworks libraries, which then actually use base libraries. So they use OpenGL, they use Glut, they use FreeImage, etc., but they provide all these wrappers so that everything looks the same when we use them, which is nice, and we can pass information. So we can pass information from OpenCV into OpenGL, even though OpenCV uses one image format and OpenGL uses another. The Open Frameworks wrappers basically say, here's a common one, so you can take an image from OpenCV and draw it in OpenGL. Just that easy. Yep, so when we look at our directory, and we already sort of looked at this a little bit, and it's not really too important anyway. We have add-ons, which are the add-ons that we get by default, and also some we've added. So I put in the Leap Motion one before in here. We have apps, which is where our apps are stored, and we have libraries, which is where the base libraries are installed, but you won't even need to touch them. The only thing you ever really need to worry about is the project generator. You're creating a new project. Apps, which is where your projects will be created, and add-ons, which is where if you want to put some new add-ons in, you just drag and drop the folders in there. So yeah, this is pretty much how it goes. Oh, and if we go into the add-ons folder as well, typically you find, sometimes this is not always accurate, so we can go into examples, and there'll be examples of stuff in here as well. Some of the add-ons that we add, so the Leap Motion will have examples in there. So it's unfortunately a little bit non-standard in there. So If it's a default add-on, so it's one of, I'm closing this because I always need it open. If it's one of these add-ons across the left here, their examples will be in the examples folder. If it's one of the add-ons on the right, so the add-ons that we've added, their examples will be in their folder, so example here. So yeah, if we just jump into one of these, let's just have a look at this. So there's a bunch of examples in here. Let's have a look at advanced 3D example. We'll start. Probably going to need to take a wee while to build this. So start it running, and then maybe we'll come back to it afterwards. So I don't actually know what this example does. So I looked at it before, but suggested exercises, there you go. If you want to teach yourself, here are some suggested exercises for this advanced thing that someone's created. Taking a little while to compile. It's always quicker the second time you do it because it doesn't have to recompile quite so much. And we just have a few more places to run. We have a few more examples. Oh, here we go. So this is what this example does. So there's all sorts of particles flying around in some light. So we can change the main view of the camera. It's locking it onto the light, and so on and so forth. So you can go through all that code and see how they've done this. But you can see this is running quite nicely. Probably wouldn't run quite as fast in processing. But yeah, so examples and stuff are in there. I'll just last for you a couple more, and then we'll have a short break. Oh, where are we? Not that one. This one. So yeah, open frameworks. If it's libraries we've added, the examples will be under there. Otherwise, there should be actually another line out here for examples for pre-existing ones. And sort of just covers the same stuff. So yeah, the three main files that we're worried about is main, which we don't ever have to touch, testapp.cpp and testapp.h. So we write our code in these two functions. This is pretty much what main looks like. So this is actually an older version, but basically sets up OpenGL and then calls run on our testapp. In testapp.h, we have all our declarations, so setup, update, and draw, as well as a whole bunch of interaction, key, mouse, window events. And then in testapp.c, we implement them. So we implement our setup code, our update code, our draw code. So typically in setup, we do things like load any assets we need, initialize values, initialize add-ons and components if we needed them. In update, we do anything we want to update as quickly as possible. So calculations, increment video frames, and draw is when we're going to draw stuff to the window. So drawing shapes, images, videos, or if you want to use any shaders. So if you remember in processing, we have to sort of jump through some hoops in order to do GLSL and stuff like that. In open frameworks, it's all there ready for us to go. And I'm going to leave it there. So we'll have a break for, say, 5 minutes if anyone wants to grab a drink, go to the toilet, and then we will start back with hardware prototyping. So yeah, let's get started on the second half. I know that was a really quick blast through open frameworks, but I just wanted you guys to be aware of it, know what it's used for. I mean, obviously some of you guys are already C programmers, so you can have a play with it in your own time and get a hang for it. We will be looking at it again after the lecture break. You can do your assignment in open frameworks if you want, but I'll leave that up to you. You can do it in processing as well, and Mark sort of suggested processing, so we don't really care what you do it in as long as it's done, but you guys have had a lot more experience with processing than open frameworks at this point in time. So feel free during the break to have a look at it, have a play around with the examples and stuff. But yeah, you don't have to use it at the moment. Because in order to get us prepared for your assignment, which Mark said he was going to come in at some point and talk to you about, If not, I will describe it to you. We're going to be looking at hardware prototyping. So you guys are going to be doing something with processing, something with hardware. So basically, there is a need for hardware prototyping because there's all these devices, and oftentimes you're sort of like, well, I want a simple wireless GPS-enabled RFID reader. So I want to go around, scan RFID tags out in the real world, be able to communicate back to some server, and I want it to be GPS located. So it might be, have any of you guys been geocaching? You know what geocaching is? So geocaching is basically a scavenger hunt in the real world. So there's a website, you go to it, and it has like, it tells you the rough GPS coordinates, and then it gives you sort of riddles that you have to solve to find these things, and then you mark down, you know, you sign your name in the little logbook, and sometimes they have little trinkets you can exchange. Anyway, you can imagine.
That's like the Pokemon thing they did.
Yeah.
Yeah,
Oh, I
but it's
heard about
real world. Like you actually go to
It actually exists.
yeah,
Real
physical.
Hey, that's my childhood dream.
But anyway, so you can imagine like a similar sort of thing, like a scavenger hunt with RFID tags that people go around and scan them, and they can use GPS to help them locate it, and it's wireless, so it records back, you know, yes, you visited this. So, you know, we have GPS devices, we have these 3G modems, we have RFID readers, but unless you're a hardware engineer, you can't really sort of wire the three of these together and make it work. So you end up building something like this, which, I mean, I've done a few years of electronics, and I still probably couldn't tell you what 90% of the components on that board are, and it looks like a bit of a shambles, and you have to be an electrical engineer to make it work. So basically, this is sort of the contrast between software and hardware. And again, you have to imagine that we've completed all the software stuff, because then these lectures make a lot more sense. But basically, you know, we've sort of, this was the productivity versus time. So back in the old days, you know, people had to write in assembler or languages like COBOL. They were really hard. You often had to sit down with a pen and paper and actually figure out what everything was going to do and write it, and then test it, especially when you didn't have access to the mainframe or something. You have to use punch cards. You have to debug it all by hand on a piece of paper, then submit it, and then if you're lucky, a day or two later, they'd come back and they'd say your program didn't work, and then you have to figure out why. As time's gone on, obviously, you know, we have these tools like open source, Java, Ruby. I don't know why Ruby's in there. Seems like an odd one to throw in there, but you know, processing, open frameworks, all these sort of things which are designed to make people as productive as they can be as quickly as possible. And that's why we've been focusing on processing and open frameworks, because they are productivity tools. They get you started programming. You don't have to worry about any of this other sort of, you know, jumping through hoops and stuff to get stuff done. However, typically hardware started with ICs and breadboards, so integrated components, or even before that, you know, valves and all that sort of stuff. And then over time, we've got ICs, and now we've got some FPGAs, field programmable gate arrays, which are sort of hardware that you can program, and then it changes how the hardware works.
Logic gates.
Yeah, but programmable logic gates. Sort of, yeah. So, you know, there has been an improvement, but, well, this is today out here actually, so this is a few years ago now. There wasn't actually like a huge amount of stuff for amateur programmers to get into and get easy. Also, if you look at consumer electronics, we've got the scale economies. So, you know, if you want to, as the market gets larger, you have to sell things for cheaper and cheaper. So, I mean, things like the amount of products which goes into a mobile phone, they're not making a huge amount of money off them. The margins are pretty slim, but they're selling millions and millions of them, so that's fine. And, you know, often you end up with this sort of curve in the product margins. So you have huge R&D costs to develop something. And it's usually only about after, you know, a couple of years that, you know, you'll actually start breaking even on these profits. So you run a huge loss to begin with. And I mean, especially look at things like, which one was it? I think it was one of the PlayStation or the Xbox when they released their new version as a competitive. They were actually selling it below cost of, like, Xbox was it? So the Xbox, they were actually selling it for less than it costs to make the Xbox. So for every Xbox they sold, Microsoft lost money, but they would be making it up on, you know, software sales and stuff like that, because once you've written the software. Exactly. So you sort of have this thing where if you want to produce any hardware in the big time, if you're lucky to still be around in 2 years and you're lucky to find this this price point, you know, $200, where you get enough that you actually make some money. Because, you know, if it's too expensive, no one's going to buy it. If it's too cheap, you know, lots of people buy it, but it's going to be impossible for you to make money. You still have to survive for a couple of years to even start sort of reaping any rewards. And your average returns over time diminish. And I mean, that's no more true than it is today. You know, you think about cell phones. This thing is a couple of years old, and it's completely obsolete. I mean, if I was one of these people who actually wanted to spend money on having the latest high-tech gadgets, this would be long thrown out, because it is kind of a piece of crap. But, you know, your returns over time, it's not like you sort of hit this point of, yeah, we're finally making some money, and then you back down the curve and you're like, okay, no, we're not making it. Yeah, try and lock you in for as long as possible.
Then offer you an upgrade.
Mm. That's more to lock you into the service than anything, than the hardware.
The hardware's turning over, every trying to turn the hardware over to the product quality.
Yeah. Yeah, but I mean, that's part of to try and keep people locked in, because if they said you have to keep using this phone for the next 10 years, nobody would go with them. But basically, there's this what's known as the long tail of electronics, which is this untapped potential. So if we look at sort of amount sold on this axis versus sort of money which is available along here, we have this huge thing. Today's consumer electronics, cell phones, MP3 players, LCD TVs, DVDs, PDAs. No one makes anything unless they know they're going to sell millions of them, because it's just not worth it. However, there's all the stuff down here where you're only going to be selling like a few of them, but you can charge more for it. That is almost completely untapped. So we're looking for new markets, things like healthcare, education, stuff like that, where they don't necessarily have, you're not going to sell hundreds of millions of units, but you can do more personalized gadgets, you can do network gadgets, all that sort of stuff. However, nobody wants to like sort of go into this market, because, you know, there's not, you know, for a single device, there's not a huge amount of money. Like, you know, if you're selling 10,000 devices, you're not going to be making a huge amount of money if it's going to take you 2 years to R&D it. So the question is, how can we break into this sort of market? So the current approach, you know, you have for hardware devices for a consumer electronics, is they start with the prototyping stage, spend, you know, $40,000 to $100,000 on that. You know, you do all these prototypes, spend 2 to 6 months prototyping it, bring it, and, you know, these prototypes are just bits and pieces of electronics whacked together however you can. Then you bring out your alpha, which is sort of similar. You build 10 or hundreds of those, that's 4 to 6 months working the alpha. You build out the betas, which are hundreds to thousands of those, and then maybe 6 to 12 months after that, we start doing our production where we're doing $500,000 to $1 million plus, and we're spending about $500,000 to $2 million. So we're looking at spending, you know, maybe $2.5 million plus, what's that, about 2 years plus, to actually get from, I have an idea, to here's a product that we're selling, we're actually starting to make some money back. And, you know, there's this whole thing as well that, you know, you don't, and we looked at this way back in the very first sort of lectures, people aren't interested so much in buying a piece of hardware anymore for its specs. People are more interested in the user experience. So you remember way back in the early lectures, we had that pyramid, you had, you know, hardware components, and then on and on and on, and then the top layer of it was the experience. We looked at the Starbucks example. You know, it only costs 10 cents to buy some coffee beans, but people go to Starbucks because they get the coffee made for them. It's a nice atmosphere, so on and so forth. And it's true in this as well. So, you know, these days you buy your Apple TV and you want it to be able to interface with your iPhone, so you can control it with your iPhone. You want to be able to use it with iTunes. You want to be able to use it with your TV. You want to be able to sync stuff from your iPod and whatnot. So you have this entire product family which all integrate with each other, and you have this experience where everything communicates with everything else. And, you know, you buy something, you have a physical interface, you have a digital interface, and you have the content interface as well. So it's not just enough to bring out a nice piece of hardware as well. It's got to be nice to use, it's got to be pretty, it's got to interact with all your other stuff. Yep. Sure. Yep. So we're just getting into the hardware prototyping now. So I'll come about 12 or just before 12.
Sure. I just need like 3 minutes.
Brilliant. So yeah, we have this sort of thing where, you know, people are expecting more from their electronics. So there's been a bunch of hardware prototyping tools which have been made. as a result of it. So there's one called Bubba Labs we'll look at. We'll look a little bit at Details. Arduino is a really popular one, which we're going to be looking at in quite a lot of focus. There's NetDuino, which is one of the Arduino spin-offs. More recently that I haven't included in here is things like the Raspberry Pi. But yeah, so these are just a few of them, obviously. There's other ones as well, Lego Mindstorms, etc., etc. So if we look at, put a few of these on a diagram with technological ability from very easy to use to quite advanced, and price from low to high, we sort of see things like, Lego Mindstorms are quite expensive. They're about $500 to get a kit, but it's Lego. You just push stuff together and you go for it. Then you get down to the other extreme. We have bare custom. So you go out to JCar, Dick Smith, you buy yourself a bunch of transistors and you solder them onto a breadboard. Dirt cheap. I mean, transistors cost like cents. But if you don't know what you're doing, you're not going to get anywhere. And then you sort of have all these other things in the middle. So, Lego Mindstorms, expensive, user-friendly, bare custom, chips and PCB. And Arduino sort of sits quite nicely in the middle where it's quite cheap. So, I think we've got you guys these kits, which were less than $100, come with a whole bunch of stuff. You can buy a plain Arduino, so Arduino is actually just this little board here. You can buy those for about $30. So they're pretty cheap, and they basically, you program them on a computer, you plug stuff into these ports on the side, and you can interact with hardware. We're going to look at how that works in a minute. But, they're cheap, and they do a lot of the stuff you want to do.
We connect it to a computer monitor, we don't have to screen.
Not easily. So that's more of a Raspberry Pi thing. But the idea, behind these, is you would have a computer that's plugged into that, and this acts as an interface. Yeah, so basically you see it's got a USB port on it. Plug a USB port into that, write your code on the computer, and it runs on that. And then you that communicates with the computer and vice versa. So you write your processing code, which talks to that. That deals with all the hardware, the switches, the diodes, everything else, and then goes back to your computer.
So I can use that with Unity.
Yep. And in fact, Natalie, who was in our master's course, not last semester, but started last year. So same course you guys do in the first semester. For her master's project, she did a thing with Science Alive, where she had I can actually show you later on, like a CAT scan type thing for Science Alive, where you have a mannequin, it had a little touch screen, you slide it over on the mannequin lies down, and it has this big, an X-ray thing you slide over and you can see inside it. And she used an Arduino to basically measure where the thing was, so it would update the visuals, and all the graphics and everything was run in Unity. So yes, not only can you use it, but lots of people are using it. And our last batch of master's students have been using this with Unity. So
We used to use a program, I forgot what it's called, 555 chip.
Yep.
High school used it.
yeah, so 555 timers again are awesome, but they fall more into this sort of stuff. So when I did high school electronics, we used 555 timers. They're a lot of fun, but they're also a lot of work. So I ended up having to prototype everything on a piece of paper, and then still took me 2 or 3 goes before I finally got it working right. So this is what you're sort of looking at. I don't know why these are in euros, but just deal with it. So you're sort of looking at about maybe $400 or $500 for the Lego kits, but they're really cool and easy to assemble. The Atmega 168, which is actually pretty much, not on that one. No, none of these ones. I do have one in my office, but that's actually pretty much what these things are running. So they have one of these microprocessors built into the board, so you can actually pull this off and use it in the thing. So you write all your code gets saved onto this, and then it interacts with all the hardware through everything else. And the Arduino is, sort of about that. Well, it's a bit cheaper than that now. I think I got mine for about $30, $40. But, it basically is one of these, but it contains all the hardware to allow you to communicate with your computer with it. It has all the power, all crystals and stuff to smooth out power. It provides all the input-output ports and all that sort of stuff that you need. What is it dinging? Oh, that's right. That's all right. I didn't realize it was coming from your phone. So yeah, I mentioned that we'd look at Bug Labs. So we'll just have a look at what Bug Labs does, because this is sort of, slides are kind of a little bit out of order, but Bug Labs is sort of a hardware prototyping system, which is a bit at the other end of the thing. So it's a bit more expensive, but a bit easy to use and a bit more sensible. So in fact, have you guys seen sort of recently this? Someone presented this big thing which made all these waves on the internet about your own phone, where you could pull out components from places. That's pretty much what Bugs Labs has been doing quite a while ago. So I don't know why no one sort of thought about this whenever everyone was getting excited about that. But yeah, Bug Labs, founded in 2006, world's first open source modular electronics program that won Best of CES in 2008 and have been shipping since 2008. So it's a 3-tier system. You have physical interface, the digital interface, and the content interface. So you plug these things in, and they all have like these connectors that allow you to connect anything to anywhere else. Then you have the digital interface where you program it, and then you have the content interface where you can, communicate with it over the web or buy stuff and whatever. And it's open source as well. So modular, 100% hot swappable consumer electronics device, open source software and hardware. Modules communicate via XML, not proprietary APIs, and completely hacker friendly. So you build your device and you say, I want a camera interface, so you can go out and buy a camera interface, or you can build your own camera interface. Because the hardware is open source, you know how you can interface your device with it, and all the things communicate via XML, so you can write your own scripts to decode information coming from them and whatnot. So some of the extensions: touchscreen LCD, cameras, GPS, motion detectors. I don't know what the hell a von Hippel module is. Arduino, Wi-Fi, Bluetooth, mini digital laser projector. 3G modem, Zigbee modem, so on and so forth. So you can buy all these little components and plug them into each other. They have the Dragonfly IDE, so you basically specify, okay, here's where all my various components are plugging into, and then, hey, it's Eclipse. You can write your code in Eclipse as well. So you can sort of design it, and the two of them plug into each other as well. So it integrates the hardware, IDE, and community, drag and drop sharing, etc., etc. And then they have their community. So we've seen this in processing. We've seen this less so in open frameworks, but it is there. We have this community where people share all their stuff as well, share their applications and whatnot. Yeah. So yeah, this is the current approach we looked at before, and this is sort of what Bug is trying to do. So, this is we moved from sort of what's going on in the labs to this consumer manufacturing stage. Here, that sort of really happens a lot later because we're sort of dealing with more tangible things. Each of these are, a bit more ruggedized, a bit more complete, really. You can actually do your prototyping on the same device that you do your pilot and your alpha with, and you can actually give these to people and ask them to go out and use them, and they're not going to fall apart and stuff like that. And only once you get to sort of your beta stage do you actually start putting it into the final boxes. So you've actually saved a lot of time. You can do this whole thing in 1 month, from building your first prototype to doing all your testing and stuff. And then, this still takes roughly the same amount of time because you still have to get all these things, all these kinks ironed out. But, we've cut almost, 6 months, or we've cut almost 5 months off here. We've saved quite a bit of money, so 40 to 100K. Now we're only paying 10 to 50K. And, we've basically sped up the whole thing, and it's a lot cheaper. So 2 times reduction in time to manufacture, 2 times reduction in cost, which is quite nice. So here's a little example of a use case. So an internet gateway for remote healthcare. So the doctor visits person, provides an examination. Then, so the pen is one of these pens which records, the writing. These things do actually exist. You click a button on the thing, and it records all the data onto your bug, they call it, and then uploads it to the internet. So it takes care of all this thing. The doctor just has to carry this around in his pocket, whatever. So it's kind of good because it's not really affecting their workflow too much. It basically, it's a bit hard to read. But
You know what that acronym is? OSGI?
yeah,
That's the Java modular stuff, Open System Gateway Interface.
there you go. I know OSG is Open Scene Graph, so
Yeah.
yeah. So the
What that's service.
gateway.
Yeah.
Gateway.
So yeah, I mean, the good thing about this is we could, go out and buy 2 modules. So we got the sort of the motherboard or base module, and then a Bluetooth module which communicates with the pen. Write a little bit of software, and basically all we ask the doctor or nurse to do is carry this around with them. So we're not actually affecting their workflow. We're not asking them to use these special devices. They can just carry this in their bag and just use this special pen. And we basically modified how this workflow works without requiring them to use anything special or anything like that. Another one is real-time content sharing. So someone visits their mother they've taken photos and stuff, and uses their gateway to basically act as the intermediary between their mobile phone and some Wi-Fi, digital photo frame. So the phone and the photo frame don't communicate directly. So we just have this little thing which sort of downloads the photos from it, puts it in the right format, and then communicates it back to the photo frame. So we're basically sort of created this intermediary product. So that's Bug Labs. It's out there. You can use it. It's a bit more expensive than what we are ideally wanting to look at. No, not sold.
I think it feels clunky, but I like the idea of it. But probably cost is the main factor.
Yeah, so I think cost is the main factor, and yeah, it is a bit clunky, but I think the idea is this is possibly more on the ease of use side than necessarily the powerful sides. This is more the processing than the open frameworks of the world. But I mean, it'd be even simpler than open frameworks. So, it's designed to be easy. It's designed for people who aren't hardware engineers to build hardware sort of thing. So, but we aren't, now these things are out there, but that's not what we're going to look at. We're going to look at Arduinos. And now is probably a good time. Now we have 2 of these new packs, which comes in a nice box, and one of the older packs. Now, who wants to volunteer to take the older pack? I was going to say you can share amongst yourselves anyway, but to be honest, they should contain all the same stuff. There you go. You don't get one. And he came by my office a while ago and got his. So now you've all got one to play with. So this programming interactivity book, as Mo's already found out, actually has, what's that?
We're not doing it now.
Oh, no, you can take them away and play with them now. Program interactivity book actually has, like you've been working through it, haven't you? Yep. And it's quite good examples of Arduino stuff in there. So, the project doesn't start until next week, but you guys can, if you're really keen to jump ahead and have a play around with it, you can do that. We will be looking at some examples in class as well. But this is an Arduino. So the Arduino co-founder said, physical computing is about prototyping with electronics, turning sensors, actuators, microcontrollers into materials for designers and artists. It involves the design of interactive objects that can communicate with humans using sensors and actuators, controlled by behavior implemented as software running inside a microcontroller. So, a lot of words, but basically, he's sort of saying that we want to, I guess his focus is, this thing here. We want to communicate with humans, and we want to be concerned with software running inside a microcontroller. So we're less concerned about building everything from the ground up. We're more interested in sort of designing interactive objects. So objects being, the completed product rather than transistors and diodes and whatnot. We're interested in this communication with humans, and we're interested in the behavior being implemented as software. So, we want to, our end goal is that we want to produce something that people can use, people can interact with, but we don't want to have to do everything from scratch ourselves. We want to just be able to use a microcontroller and be done with it. So what is Arduino? It's open source. So it's open source hardware, open source software. It's easy to program, simple IDE, which might be somewhat familiar to you guys because it's processing. So they use the same IDE as processing to program the Arduino.
So you can use processing.
Yep, well, processing can communicate with it. The language is more based on C than Java. So it's simple enough that, you should be able to sort of look at it and go, okay, yep, this is pretty much the same thing. and a simple hardware abstraction API. So does somebody want to, can I borrow yours? Since you got, I mean, you can open them and start having a look at them if you want. But so yeah, this is basically your Arduino here. Well, you guys can see yours through the window. Do they have a breadboard as well in the box? Yep. So the idea is you do all your electronics prototyping on here, and then you plug it in. You plug this into your computer. It also has a DC jack, so you can power it from, like, once you've programmed it, you can just go and deploy it. So, you know, plug it into the wall.
How do you do that without a screen?
Well, you write the program. So say we're doing something which we're making our own dimmer switch for a light. So we attach a light here, we put the dimmer switch, then we program the code, upload it to it, and then we just go in and plug it in, and we've essentially got a lamp with a dimmer switch sort of thing.
Well, you use that light to control it,
Then you'd have it plugged into your computer. So yeah, depending on what you want to do, if you want to interact with a computer with it, obviously it either has to be plugged into the computer, or you could use Bluetooth or Wi-Fi or something like that, or alternately just leave it plugged into the computer. If you want a deployable thing, so you want to build a weather station or a people counter or something outside which doesn't need a computer, you know, you just plug it in outside, or you know, there's various people have used. You can use batteries, like it just runs on 9 volts, I think. So plug a 9-volt battery in. Some people have plugged them into solar panels, so they power themselves. So on and so forth. Yeah, so simple hardware extraction layer. So you see at the top we have these ones here, which are digital I/O. Yep, they're the digital I/O. And if we want to, so digital, I think it's either 5 volts or off. So if we want to turn one on to 5 volts, we say digital write A1 on, and it will send 5 volts out on A1. Or we say digital write 5 volts, or digital write A1 off, and it'll set it to ground. So we can, you know, if you plug an LED into that or whatever, from that into ground, and then you say on digital write A1 on, it'll turn the LED on. Digital write A1 off, it'll turn the LED off. Down the bottom we have analog ones. I can't remember the exact syntax, but it's something like analog write. Sorry, those are D up the top, so that would be D1, not A1. Analog write A1 128 would put it at, I think these go, I can't remember what the highest voltage, I think it might be 5 volts again, it might be more. Well, I'm sure it's in the slide somewhere, but 128 would be 2.5 volts, because it's 0 to 255 being increments from 0 volts to 5 volts. Yeah, so nice and easy hardware extraction layer. And there's digital read as well, so you can read as to whether something is on or not, and analog read, which tells you, you know, if you're using a potentiometer, like, pretty sure there's one in here somewhere.
How much kind of hard?
It depends on the Arduino you're using, so they have different flash memory and stuff like that as well. I'm not sure, you'd have to look up. It's probably in the manual somewhere, it talks about it. But yeah, so it's an electronics prototyping platform, a basis for other things or products. So plenty of people are using them all around the world for various things. Oftentimes overkill, because you don't need that much processing power, but you know, you can get things done quick and dirty, and they're so cheap that, you know, if you're building something, it's $30. Who cares? Just leave it. Yeah. So this is the Arduino as a board. We have a USB port. USB port here, power supply here, USB to serial. So all communications with Arduino is done by serial communication over USB, which is quite nice, because then we can use, like, processing provides a serial library, Open Frameworks provides a serial library. We can communicate with these things really easy. Up the top we have our digital I/O pins. So, you know, 0 volts or 5 volts. You can also do pulse width modulation and whatnot with them if you really want to. Down the bottom we have power pins, so you can either power your Arduino off these, or you can actually power stuff. If it's plugged into a power supply, you can power other devices off them. So you get 3.3 volts, 5 volts, a couple of grounds, and I think these two are if you want to power it, rather than using the power supply, the USB ports. If you want to run a couple of wires directly in there for whatever reason, you can power it off there. And then it'll provide 5 volts out, 3.3 volts out. And you have reset and a reset button if you need to. So your program, basically when the Arduino turns on, it starts running your program. pushing reset will restart your program from the beginning. And you have analog input pins as well. So yeah, it's pretty much what we just saw before. Digital pins. So some of them, which ones? These two, if you're doing serial communication, you can't use these ones. Otherwise, that's fine because they're doubled up. Reset button, digital pins, digital ground over here, analog reference pin, in-circuit serial programmer. So we have this thing which actually allows Arduinos to program other Arduinos or other devices, so you don't actually even need to use USB to program it. You can use these pins over here to program it from something else. Power and ground, external power supply, toggles external jumper, so not all of them. In fact, this one doesn't. I don't think the other ones will as well. So this is for an older one where you need to select if you want to use USB power or other power. I'm pretty sure most of the new ones just use whatever's available. And USB for communication and power. So as Jonathan was just asking, what are their specs? Well, it depends on what board you get. So you have the Arduino Uno, which is what Jonathan's got, which is an older one. So one of you guys may need to swap with him if he's doing some higher processing. Sorry, we didn't get enough of the new ones to go around. But to be honest, you know, it's one of those cases that you're probably not likely to run up against the limit anyway. And this, yeah, well, this will do everything that those will do. Those essentially just have a bit more space on them is pretty much the main difference. So there's the Uno, there's the, I can't even pronounce that. So the Arduino is Italian. So you'll notice a lot of the names are Italian words. I think Do Milanove, I think is Italian for 2014. No, wait, 2004, sorry.
I know Uno is one, isn't it?
Yeah. What's that?
So Nova is not new there.
I don't know.
That's French. All of those languages.
Yeah, no, so Uno's one. I think this is like 2004 or 2000 something, which is when the board was released. LilyPad, so this is one which is typically used for wearable computing. So it looks like a nice badge, it's very pretty. A lot of people use them if they're making like wearable sensors and clothes or something because it's less like sort of computer looking. It looks more like an artistic sort of thing. And it's got all of these pads around here are basically these inputs here, so you can solder wires on them. People do electroluminescent clothes, they sew things in them and control them with that, or you know, put touch sensors in so you can have an interface where you touch parts of your clothes and stuff. The Nano, which is small, the Mini, which is also small, the Explorer, so this might be more interesting to you because it is a gamepad. So it's a little bit hard to see, unfortunately, but this is an analog joystick. Then you have your 4 buttons and your typical thing. I think one of these, I'm not sure if this one does, I think maybe has like a little swipe inductive touchpad sort of thing across the bottom, and then it's got various other like, looks like maybe a piezo speaker there and maybe some other stuff there. This, again, the slide is old. We go on here, Arduino USB, Arduino Mega, Arduino Theo, LilyPad Arduino, various iterations of them, Arduino Nano, Arduino Serial, Mini, single-sided serial, mini USB adapters. Yeah, so there's lots of different ones out there, and because it's an open source hardware, like every Tom, Dick, and Harry is building their own boards for them for various purposes. So there are ones which support the ADK, so for Android, so you can communicate with it directly with your Android phone and program it using the ADK. There's the Mega, which is big. So you'll notice it's just got an absolute ton of ports on it. So digital port, like 30-something digital ports, a whole bunch of communication ports. Not sure what those ones are. 12, 15, 16 analog ports. So, you know, if you need to interface with a ton of sensors, this is the way to go. The ADK, or the Mega ADK supports Android as well. So they now have released 32-bit ones, which run ARM as well. So the same stuff which is in the Raspberry Pi and cell phones, stuff like that. There are Arduinos which are, instead of being based around the Atmel chips or the Atmel, well, these older chips are now based around ARM as well, so you can write ARM code for them, but still have the same sort of interface. And in addition to that, they also have what are known as shields. So shields, you'll notice that all the Arduinos sort of share this, well, the main ones anyway, the larger ones, share this sort of common shape that, you know, they've got analog and digital on one side. Then you have these shields which have analog and digital, but they also plug in and they provide stuff such as network connectivity. So, of course, you can buy an Arduino which already has a Ethernet port on it. Or alternately, if you're using one of these, which doesn't, you can go out and buy a network shield, and then you just import the Arduino network library, and then your Arduino can communicate with the internet. So you could use it as like a weather station, which is outside remotely and communicates back over wireless or something.
How do you connect the shield?
The shield just plugs straight into the top.
Okay.
Yep, just pushes down on top of it. So here we go. So here's an input shield down here, so you can see the Arduino underneath it, and it's just pushed in on top of it. And you notice a lot of these shields, like this one here, has the pins on the bottom and the headers on the top, so you can actually stack shields on top of shields. Yep. So these are just a few of the shields which are commonly used. So motor shields, this has an H bridge and takes 12 volt in, stuff like that. So your Arduino can control motors without worrying about burning it out. You can sort of drive them off these, but there's a good chance because motors have various things. They often pull a lot of current when they're first starting. If they're not properly isolated, when they stop moving, they produce a huge amount of electromagnetic interference back down the line. So if you plug a motor back straight into your Arduino, you're very likely to burn something out on the board. So you can buy a motor shield which can control it, or obviously you can just create your own little motor thing on your breadboard to control them. Micro SD. So if you're doing something remote, you want to stick an Arduino out in the middle of nowhere and come back and pick it up every so often, and then you're storing a whole bunch of environmental data. Plug your micro SD in there, save data onto the micro SD. Touch shield, so if you want to control your Arduino without a computer, you've got a screen and a touch shield. Smart meters, so if you want to plug that straight into your power meter at home and find out where you're using all your power, play MP3s, an input shield, which has a little joystick and button and stuff on there as well. Communication shields, Ethernet, Wi-Fi, RFIDs. This produces a little RFID tag on its little e-ink screen that you can capture with your phone or whatever. Wi-Fi, which is sort of like Wi-Fi but different. GPRS, so you can get GPS information. Bluetooth. Here's another shield sitting on top of an Arduino.
How expensive are the shields?
Depends on what's on them. So some of them, usually maybe $20. So they're actually often about the same price as an Arduino.
It's a bit modular too.
What's that?
It's a bit modular too, isn't it?
What's that?
Like things.
Oh, yeah. So it's designed like, you buy your Arduino and then you can either do all the stuff by yourself or you can buy another module to plug into it and they'll provide, the code to do it.
Where did you buy them from?
Pretty much anywhere.
Like Dick Smith.
I don't know that Dick Smith does. I think JCar probably does. Dick Smith these days are pretty consumer electronics, so they sell TVs. I would say you probably buy them from JCar. Otherwise, I think I got mine off Trade Me. Lee got these off Element 14, I think it was, which is like a New Zealand online. Wow, it's a worldwide online electronics retailer and stuff like that. GPS is ZB, which is a wireless communications protocol. Radio frequency, another radio frequency. So yeah, you could communicate. If you've got a radio controlled car, you can, or quadcopter or something, you can control it over your Arduino. So Arduino supports digital and analog I/O. Means it's capable of interfacing with numerous devices and sensors in addition to the specially designed shield. So you could use a shield to do something you wanted, or you could just go out and buy something from Dick Smith JCar and start using that anyway. And a lot of these devices already have Arduino libraries, which makes interfacing with them simple. So you'd use, P0 buzzers, vibrators, relays, LED matrices, OLEDs, LCDs. I actually bought an LCD off Deal Extreme. So do you guys know Deal Extreme?
No.
Deal Extreme is kind of cool if you're into gadgety stuff. So it's this massive retailer which sells everything online. They are based in Hong Kong, although they do have Australia and US branches now. But the good thing about them is worldwide shipping is free. So you can go on here and search Arduino, and there's a flame sensor. So if you want to detect if your Arduino is caught on fire, $3.66 free shipping.
How long do you have to wait?
2 to 4.
Yeah,
2 to 4
usually about 2 weeks.
Oh,
That's not bad.
It looks like eBay software.
Yeah,
Not eBay, Amazon.
yeah, sort of, but usually cheaper.
It's cool.
So stepper motors if you want to build a controller for a 3D printer, alcohol sensor if you want to make a breathalyzer thing.
So you
You
can
know-
build a 3D printer with your
Right?
Yeah.
You can what?
There's a 3D printer
You can build
controlled
a
by
3D
Arduino.
printer with a
Wow.
Oh, here we go. So Ethernet module, $15. That's US, but I mean, you know, it's a good time to buy because the US dollar's pretty crap at the moment. So,
Yeah.
you know, keypad shield, a VGA camera module. So if you want to do some image processing, have a security system, you know, you could set up your own home security system, buy one of those. $15 plus $10, and then it plugs into your internet, and then you have a network-enabled security camera, which is controlled by Arduino.
Can this take an SD card or?
Yep.
Oh,
Well, you're not paying attention.
Yeah, I'm paying attention.
Right there, micro SD shield.
I didn't hear that. I got distracted when he said touch it.
Right, and then so obviously these are higher end ones. Then you've got like your more basic ones, so photocells, color sensors, rotation sensors, potentiometers. You guys should have some of these in here. If not, go raid the hardware lab because they got lots of them in here. There is stuff in here. So you guys got motors, LEDs, flex sensors and buttons. So flex sensors detect when they bend, resistors, servo motors, other stuff. So it looks like Jonathan is missing his potentiometer, but that's okay. You can. So a potentiometer is a resistor that you twist, so like a volume dial on something. So one of these, essentially, you twist this part and it changes resistance. Joystick, sound sensors, water sensors. What's that? Yeah, there will be stuff down there. Temperature, humidity, IR, passive infrared, accelerometers, inertial compasses, ultrasonic sensors, AC current, Hall sensors, CO2 sensors, flame sensors, flex sensors, infrared receivers, thermometers, smoke detectors, pressure sensors, pH sensors, real-time clocks, heart rate sensors. You can do a lot of stuff with the Arduino. It's quite cool.
Maybe like the point kind of thing, like the connectors. That's in that infrared.
Yep. So you could do that. The processing on them probably is a bit slack for that, but you could certainly do it. And I mean, with things like the ultrasonic sensors, you can get the distance of objects. Ultrasonic aren't as accurate as like the Kinect. It usually only sort of tells you one object distance. But there. Okay, so let's just quickly whip through these last ones and we'll get Mark in here. As I mentioned before, Google got on board and started releasing ADK versions of the thing which communicates with your mobile phone, so you can write something on your mobile phone, your Google phone, and control your sensor. So you can imagine, you plug it into your home lighting, your heat pump or something, you control it via your mobile phone. So yeah, with using the ADK stuff, you can find the best of both worlds. Your phone's got Bluetooth, GPS, Wi-Fi, runs Java. Some of them have TV and FM, not many these days, but you've got camera, you've got compass, you've got light sensor, gravity sensor, vibration, and you can then use that, send all that data onto your Arduino, and get it to respond to that. So you could have something where you control the light levels in your house by tilting your phone or whatever. You can, all of the stuff that your phone has access to, you can communicate over to your Arduino as well.
So if you had everything like your internet cables in your house to an Arduino.
Yep. So you can do some quite cool home automation stuff. And actually, just another. So this is actually a site I try and sort of visit every day. It's called hackaday.com.
You should give us more of the sites.
Well, you guys have to do some work eventually. You can't just be browsing blogs all day. But Hackaday is this quite cool blog, and it's hack in the white hat hack, like the productive hacker rather than the Yeah, rather than the destructive people. So these are people who basically they buy hardware and it doesn't do what they want it to do, so then they modify it to do what they want it to do. So there's plenty of stuff on Arduino. So boxing plus Arduino plus geometry exordinous. Imagine a machine you could throw a punch at, would locate his fist in real time and move a punching pad to meet his moving fist. That sounds pretty counterintuitive because ideally when you're boxing you want to be able to control where you're hitting rather than having the thing move to hit you. If you're in a fight, the person's probably not going to step into your fist. So this doesn't sound like the greatest use to me, but it kind of seems a little bit counterintuitive.
Sounds like Mike Tyson.
Yeah. But yeah, so there's lots of stuff on here. Talk about various bits and pieces. There's always Arduino stuff which comes in, but you'll actually notice somewhere in here. Oh, there we go. We go to categories, and you'll see down here they have 1,280 Arduino hacks in there already. Stuff about 3D printing and stuff. We go into the Arduino hacks. A lot of people doing really cool stuff. Not this guy. This guy. But
Landing page stuff.
unlocking your computer. So somebody who has used an Arduino to type in his password on his computer. Oh, this was kind of cool. Someone did the other day using an Arduino. So this is more on the black hat side of hacking. They put an Arduino inside their mouse. Then you plug your mouse in, and it, like Arduinos, typically you can basically change the firmware on them to enumerate as different devices. So he did one which enumerates as a mouse, and it forwards controls from the mouse as well. So your mouse goes into your Arduino sends that to your computer. But when you click a certain number of times, the Arduino takes over and starts sending a whole bunch of information out. So he did it when you click 3 times, it takes control of your browser and sends your browser to a specific website. So kind of cool. Little bit on the black hacking side. So this is obviously one of the smaller Arduinos.
You're trying to do a zombie thing.
Well, the idea is, it's a new way of hacking into a computer. You just take along your mouse, you plug it into your computer, and you tap Morse code on the buttons, and then it opens up a secret thing which starts recording information out or sending your computer to do uploads.
So you can plug into anybody's computer and just go.
Yeah, you tap a couple of things. You can imagine, if you wrote a program which run some malware rather than having to deliver on a flash drive or whatever, you plug your mouse in, tap a couple of buttons, and then it opens up Notepad, prints out the entire quality of the program, saves it, and then runs the program. So you've effectively got a new vector of getting stuff in there. Some guy hacked an Xbox One using an Arduino Xbox One controller. Door handle. Arduino Day was the other day. Etch-a-Sketch, which is controlled by an Arduino and a few motors. Plenty of stuff on there to draw inspiration from. Quite a cool website. As I said, I check it most days. Anyway, let's get on to these last few slides. So we've looked at the hardware side of it. Let's look at the software side of it. The Arduino IDE should look quite familiar because it is processing. They've just modified it a little bit. So you type your code in. Funnily enough, it has this setup and this loop function that we've seen so many times before. So you set pin mode 13, so sets pin 13 to be an output rather than an input. And then in the loop, so loop just runs as fast as it can. Digital write 13 high, so it turns 13 to output 5 volts. Delay, which is wait 1,000 milliseconds, so 1 second. And then the next line of code, which we can't really see, is delay write 13 low. So the idea on a lot of Arduinos, pin 13 is, so on this one it's actually got a pin 13, but some of the older ones, or some of them, it's actually connected to, I think that L, that's actually a SMD light on there, and running this code will blink the light on and off at 1 second. So the IDE is open source, cross-platform, Windows, Mac OS, Linux, simple UI. It's got lots of built-in examples. We'll look at this more next week as well, but just like the processing one, you drop down, you got new open sketchbook, examples, basics. So read from serial, blink, fade a light using pulse width modulation, digital analog communication control, sensor display, strings. Then you've got stuff for working with EEPROM, Ethernet, firm ATA we'll look at later on, liquid crystal displays, SD cards, servo, software serial, SPI, stepper motors, one wire interface, so on and so forth. It's got some built-in commonly used libraries, so EEPROM is obviously electronically erasable programmable read-only memory, so it's data you can write to and it'll save. Ethernet, networking, firm ATA, we'll look at later. Liquid crystal displays, SD cards, servo motors, running serial communications, SPI and wire communication protocols which run over bare wire and stepper motors as well. They have the Arduino website, so now that we've looked at all these other unrelated websites.
If this can take an SD card, it can then take an Android iOS onto it. What's its processing and graphics card? Should avoid it.
Sorry, what was it?
If you can take an SD card, then it can take an operating system onto it.
It's already got an operating system.
Arduino.
Yeah. Yeah, so what you were talking about is more what the Raspberry Pi does. So this is the Arduino website. It's quite nice. You can download all the software. So you can download the software for various things. Products, so you can look at the products, the boards, shields, kits, accessories. There you go, TFT LCD screen. Beautiful. Lots of stuff in there. And lots of educational, getting started, examples. And then they have all the forums, and they've got quite a good community and stuff like that as well. Installing the IDE we'll look at next week, and we'll probably look at the rest of the stuff next week as well. Yep. So I mean, that's just looking at how to program it. So global variables set up in a loop. And yeah, so I will go grab Mark now, and he will tell you about your project.